Swayam Prabha. Digital India. Educated India.
So today we will be continuing with the second lecture of module 5, which was on prefabricated concrete construction. So what we had learned in the first lecture is it was a dry construction which was more or less not much involving labor, considering the skill of the labor. So we only required skilled labor, but yes, all these materials are being made in the way it is being cast as a cast concrete, and it is cast in a very controlled environment. So today we will try to cover the three units which are more or less similar to building blocks, but larger in size, which are mostly for the walling purpose. One is the concrete masonry unit or the CMU, which has again two types. One is a solid one and the other is a hollow one. Other is the aerated autoclave concrete block. So these two blocks are extensively used in building industry as an alternative to brick, because if we look into, when we will go into the next lecture which is on precast wall panel, you will see how how skill is important over there. So if we do not have a trained skill set, it is very difficult to move on or move forward with the precast walling system in our country context. However, these CMU and AAC blocks have penetrated into the industry, building industry, and we need to know both of these as a walling material. The other that will be covered here is also another unit which is very much handy, similar to, very less in weight, also not much heavy, which is again another precast block where we are not using our clay or burning process, rather we are using concrete and we are calling it as pavement blocks, which also you more or less see it when you are walking in a city like areas. So you can you see it in parking areas, walking areas, marketplaces, footpaths. So these are called pavement blocks, which are also precast items or precast concrete units. So let us move forward with knowing these items, how they look, where are they used, what are their characteristics and what are the ingredients they are made of, and gradually we move to their use and advantages and disadvantages. So here comes the concrete masonry unit. They are solid. When they are solid, it will be full. Now you are seeing the pictures which are all of units which are hollow. You can see a central piece which is called the web. This is the web, and you can see some small projections at these ends. You can see here also there is two projection. In the next one, you see this is a corner unit where only the projection is one end and this side is flat. This side is flat. In this unit, you see there is a very thin groove cut, which is to receive any glass piece, that is sash. So you can receive a glass piece through it. So you are having this kind of groove, and this is a all purpose brick which does not have all the four faces or the verticals are flat. So this helps in interlocking maybe. This is a corner unit, this is a sash unit, and you can see even jamb units where one of these edges will have a profile of this kind and it will have hollows. So whatever is the requirement, you can actually select your piece from the lot and use it. But what is the difficulty? Can you cut it? It is not possible. So, you have to move for a modular plan. So, everything should be given to you in advance where this kind of window will come and will bear this sash unit, or where a door will come and you have to have a jamb unit, or where you are going to finish, there you will have a flat end. So, this is how you can have multiple options and you can carry forward the construction process, but these are much bigger in size as compared to brick, which we had seen. So, this makes the entire process faster. So, let us see the next, which is already displayed, which is autoclaved aerated concrete block. As you can see, it is having a very neat finish on one side, and you can see that these are not having any kind of hollow inside it. These are solid in core, but as the word is autoclaved aerated, means it is full of air or pores. We will see further details, but let us see the other unit which we will discuss in this particular lecture are the pavement blocks. You can see a number of, this is a plan view of the pavement block, where these pavements are actually one set beside the other, and you can see it is locked. So, this is totally a dry way of doing it, and it is mostly done in parking areas, on footpaths, etc. So, all these are maintaining or complying the standards with respect to its dimension, density, water absorption, shrinkage and compressive strength. I am not going into detailed parameters of each of these, but as a comparison, they are not that much absorbent towards water. They do not have defects similar to brick, like they do not have efflorescence, etc. They have compressive strength a considerable amount, those I will be reporting you, and these are the IS codes, which are IS codes numbers, which you can always refer to if you want to get more input on this. Other than the hollow blocks, concrete masonry units come as solid blocks also, which are used for load bearing structures. Now, coming to the dimension, this whatever it may be, hollow core or solid core, it will have more or less or typically 400 millimeter into 200 millimeter into 200 millimeter in dimension, that is replacing almost 6 bricks. But yes, you can have, instead of 400 millimeter, you can have 600 millimeter in dimension, that is 2 feet size in length. You can have 75 thick, you can have 100 millimeter thick units for the internal partition walls. So, these units regularly, typically they are of this dimension. However, you can change the dimension when you are ordering, the molds will be accordingly used. So, these all are molded out. So, brick was a molded unit, but after that it went in for burning. But here these are made of, mostly it has cement in it and it requires the hydration part and for its gaining strength, and it is to be cured for 28 days. Whereas AAC block, you see 2 A's are there, one is for the air, as I told you, aerated, and one is for autoclaved. So, this autoclaved aerated block, concrete blocks, they are cured under heat and pressure in an autoclave. So, this is the major difference, and we will come into the composition also, where you will find it is quite different from the CMU. Unit weight of CMU hollows are 12.7 kg is solid, it is 17 to 26 kg depending on the compaction it is done, depending on the materials, the density of the materials, and the strengths are also given, which is more or less replacing brick when it is brick or more when it is solid, and when it is hollow you can see it is 4 Newton per millimeter square. So, it is acting as a non-load bearing wall. So, it is a filler, it is standing between the structure. Coming to the AAC block, 80% of it can be air. So, these are much lighter in weight compared to the CMU blocks, CMUs, and it also has an approximately low compression strength of up to maximum strength is up to 8 Newton per millimeter square. So, you can well understand it is at par with brick, but having larger coverage, lesser joints, larger faster construction, less water absorption, even you can avoid the plastering part. If it is a dry area, you can avoid the plaster. Inside you can aerated concrete, autoclaved aerated blocks are very smooth, as we had seen in the picture. So, what is happening is you can avoid the plaster component, there is a savings, because it is having air inside it, it is acting as a good insulator. So, hollow core of the CMU can be connected by reinforcement rod to keep it in position, and you can even have it can face impact load. As I told you, hollow blocks are not experiencing the taking the load. So, they may be experiencing some impact force, lateral impact. So, you can actually connect the hollow blocks through reinforcement bar. So, you can have a set of hollow blocks placed with their webs, etc., and you can have a wall being made of it. So, again you can have a half smaller dimension, you can have continuous walls, vertical lines also unlike brick, and you can actually push in a different rod through and through at intervals that will pass, and then you fill it with concrete. So, this concrete will be inside. So, you are pouring concrete. So, you are reinforcing with some rods at intervals when you are making the hollow block wall. So, this is how you can strengthen your hollow block when it is in a wall system. The hollow block advantage is, as you saw, the units are much lesser in weight compared to the solid blocks. They provide thermal insulation because of the air entrapped in the hollows, that is the air entrapped within it. Similarly, the AAC pores are acting as the pores in the AAC block are providing thermal insulation. They also help in fire resistance. I had already explained special jam blocks, sash blocks are designed to receive door window frames. So, unless and until you have a plan, you cannot move forward with these kind of blocks. Now, coming to how to stick each other. As I told, it is not completely dry. Yes, it has a application of mortar similar to that of brick, and it is mix 1:6 is the cement sand ratio of the mortar, and they are very thin. In high temperature, to avoid shrinkage, an addition of lime may be added. So, then the proportion becomes 1:2:9, and it is mostly used for desert area, hilly area, where further shrinkage can be controlled by using calcium chloride, half kg of calcium chloride per bag of cement. So, these are some typical mortar mix to be used, and as the number of joints are very less, as the number of units are less, so joints are much less in number and they are thin too. Now, coming to the ingredients, what makes the concrete masonry unit or the AAC blocks. First, we will discuss the concrete masonry units. You see, it is Portland cement, sand, clay and shell or slate in dust form, which are the basic ingredients, and you can add the admixtures which help to make it little lightweight, that is slag, fly ash, which are coming from the industry. But unlike CMU blocks, you see the composition of aerated autoclaved aerated concrete is quite different. It contains gypsum and aluminium powder, very little, 0.05 to 0.08%, but which actually reacts with calcium hydroxide and water which you are mixing while preparing, and hydrogen is liberated. This hydrogen gas actually foams and doubles the volume of the concrete itself. Similar to the other materials of CMU, you are adding gypsum and aluminium powder which reacts with the calcium hydroxide, increases in volume and creates a lot of bubbles inside the material. The hydrogen eventually escapes and it is replaced by air, forming aerated concrete. And as I told you, around 80% may be air. So, this has led it to be light in weight. So, working with aerated concrete is much easier than working with the CMU blocks which are quite heavier. And you can see this is a picture which I have taken, which was a broken AAC piece from site, and you can find out the pores inside. Hope it is visible to all of you. You can see the pores. These are the pores which have formed inside it. And if you happen to come across some AAC blocks, you will see they are very light in weight, and with that you can differentiate between a CMU block and a AAC block if it is not hollow. So, coming to the high strength CMU blocks, they will be added with further gravels, that is coarse aggregates, and they also require some curing for 3 to 4 weeks. Water is sprinkled on the blocks, whereas as I told you, AAC products are cured under heat and pressure. So, now coming to the fixing, if it is a concrete masonry unit solid, it can take the load. If it is a reinforced structure, if it is a beam column structure with concrete or a framed structure with concrete, you can keep on placing your units and get the desired wall. But if it is fixed against steel columns, here are the details. Why do I say steel columns? Because these units can be used for high rise structures. The structure may not necessarily be a beam column structure made of concrete, it may be a steel column beam structure. So, what you see here, the joints, which is important and which I will explain. See the joint here, one side will be the inside, one is the outside. Here also the same thing, the joint. Here the I section is in the direction of the wall, here the I section is bit rotated, at 90 degrees. So, here there is a chance it will come and match, it can even get into, it is depending on the structural design. But if it is not setting inside, you have to seal this point. So, this is the sealing point, and you see here there is a backer rod, one is the backer rod and in front of it is the sealant, in front of it is the sealant. So, the backer rod is a flexible pipe and the sealant which actually holds it, seals it, will actually come like this. So, sealant cannot enter inside completely. So, this backer rod is giving the flexibility, the drift, you see the frame drift, it will allow any kind of movement, expansion, thermal movement, sway. This sealant and this backer rod will be the cushion, and at the same time it is giving water seal. So, no water can enter inside. How are they two tied up? You see here is a fastener, here is a strap, steel strap, this is the steel strap, this member. This steel strap is bolted on this face, on the other side it is embedded on this concrete. So, this is this is mortar, as you see this is mortar, and this is, see, you can see the rod reinforcement which is keeping it stable, continuous. So, all the blocks here are tied by this rod, one after the other. So, if you see the section, it will be like this, where you have the steel column and the rod is actually passing all these blocks, and this is finally jammed with the mortar. So, this behaves as a continuous wall connector. So, there are two details here, one is the strap connecting the I section with the CMU, and the backer rod and the sealant which is giving it weather protection and any kind of expansion movement of the entire structure due to any reason. So, let us come to the advantages of CMU and AAC blocks. It is similarly constructed, it is to be made as cast in situ concrete, it is labor intensive when it is made in the factory, but transportation cost can be avoided if the raw materials are locally available. Thermal performance is better, whatever you get with 250 thick wall, 250 thick brick wall, you can get the same with 200 thick such walls. A significant reduction in cost and increase in floor space, because you are trying to get a same efficiency with 200 thick wall. These units do not require plastering if it is on the internal face also, because they are very smooth in nature and can be produced in remote areas also where there is no brick concept of brick. So, here are some collected images, you can see the free images where actually they are set and it is much faster in nature, the construction process is much faster in nature. Coming to the disadvantages, they cannot be cut into as many shapes you want, as many sizes you want. They are to be planned, building are to be planned in a modular way matching with the dimensions of the CMU. Accuracy is also very important, because they will finally go and merge with the main structure, or if it is load bearing, it has to go and end at a certain point. So, for every 10 meters there should be a check. It is preferred that shapes are square, rectangle, angles are not much suitable, and special pieces can be ordered or manufactured according to requirement. Now, let us move to the third item, which is the concrete pavement block. As I have already told, these are mostly seen in footpaths, parkings, marketplace, public spaces, etc. it has a benefit or a reason for that. These units are interlocking in nature. If you remember the previous shape, which was something like this, there also there was a pattern which was locking with another member, and this was continued. This was continued. Here you see the pattern has changed to a more or less triangle with circles. So, you can generate such various shapes, but you have to remember the principle is of interlocking. So, why interlocking? So that you get a smooth finish and no gaps are there, and there is no joints also, and you can get a continuous surface. What are the advantages of that? Advantage is you can always pick up with a little effort any one piece, and you can open up the entire assembly. So, it is important that you have to propose such units in areas where you need to access sometimes the city level infrastructure. It may be electrical line, it may be water line, it may be the cables for internet. So, many lines are moving or passing underground the surface, and wherever it is moving, it is mostly following roads, and whenever you are using it, you can always access the ground beneath it. You do not have to break it. So, these are recommended, and this interlocking helps in sharing the shear, bending, thrust force between their adjacent blocks, and finally, the load is shared to the ground. They are more or less within 1 feet dimension, but 1 feet cross 1 feet dimension with different shapes, alternatives, which will have the interlocking arrangement. Here you can see if you observe the pictures which are taken from site, you can see there are lots of dots like structures or dot like impressions on top of it, which makes it skid resistant or and it is the wearing face, because you are always walking on this face. So, they may have different patterns to interlock, and they usually do not crack due to thermal changes. They are continuously exposed under sunlight. Coming to the thickness, which is important point, is it varies from 50 millimeter to 120 millimeter, and that should be selected considering the flow of traffic over it. It may be a cycle track made with this kind of tile. It may be a running track. So, let us come to the composition and then the uses. It is crushed, semi-crushed aggregate. Maximum size is 12 millimeter depending on the load it is going to carry. Blast furnace slag, silica fumes, fly ash and cement. They are mixed in definite proportions and molded out. I have already referred to the code which is to be followed, the standard which is to be followed, and they are cured for 28 days. As you had seen, coloring agents may be added, but let us come to the main point. Where are we going to use them, and what is the type which we are referring to? So, where it is no traffic, that is only human traffic like building premises, some landscape, some public garden, patios where people will be walking. As architects, you all might have come across these spaces. Light traffic, we call it pedestrian plazas, shopping complex, car parking. See here the grade is varying from M30 concrete to M35 concrete. Medium traffic is streets, city streets, footpaths, adjoining roads, markets, and see the thickness has changed from 50 to 60 to 80, and then for heavy traffic like railway station areas, bus terminals where lot of porters, movements, luggage, things are heavy materials are may be carried. So, that is heavy traffic. Yes, you have again another category, the docks and yards, they have very heavy traffic, and those bring the 120 millimeter size. Coming to their placing, as they are interlocking units and you are not putting any kind of mortar in between, they can become loose at any point. They can just come out from the edge one by one, they can open. So, you have to have a edge binder. So, you are having an edge binder. What you see, it may be a concrete masonry unit holding the tiles in position. So, these are the tiles, whatever be the interlocking pattern, this is a simplified version, and these are placed on stable earth, that is rammed earth. And what is done? You are filling it with sand. These are all filled in with, the gaps are filled in with sand. Why sand? This sand will move down. This sand will actually give the stability of these blocks. So, whatever load is falling on this, if it is not falling on this, this can go down, but the sand will move that side and will stabilize the whole thing. So, this will not be damaged because of any soil erosion, neither will be disturbed by earthquake. At no point it will be disturbed unless it is humanly picked up, it will stay in its position. The other is, you can always access the infrastructure which may be below this rammed earth. So, you can open a few and you can actually access the pipe or the cable tray or the trench which may be underground. Another important benefit of it is, which is not pointed or noted, is ground water recharge. So, in case of heavy rain also, the water will percolate through these gaps and water will seep inside the earth. Any replacement of a damaged unit can always be done. So, it will always remain complete and any kind of movement can happen on top of it. If you keep all these main points in mind, this is what this precast item is what is the purpose of this precast item is to give coverage to many bare locations which can be dressed and made usable for put to various uses. This is a very fast process. You have to make the earth and keep on moving forward. So, we can conclude that although these are very similar to brick, but they provide faster construction, the CMUs and the AAC blocks. The joining is also very simple, easy, and it is mostly used for walling purpose. There is no efflorescence, no plastering required for dry areas when we are using this. Pavement blocks on the other hand help in groundwater recharge and does not affect any surface movement, gives easy access to underground service lines, whereas at the same time gives a dressed flooring for parking, for movement, for cycling, for for public spaces, for landscape places. And we now would like to move to the precast panels, which have not been much into our use in our country context. Thank you.